Okay, good morning class. Today we'll be doing CPCTC. I know you don't know what it means, but we're going to talk about it. Okay, so really loud. Yay math?
Yay math!
What?
Yay math!
Okay, cool. Who messed up? Was that you? Yeah. Funny that happens. Here, candy for you. Okay, nice catch.
What'd you get?
Chocolate. All right.
Wow.
So please draw the following. All right. Today's lesson's not too long. You can draw it right in your packets, wherever there's room in the 4-4 or 4-5. Love the sound of wrestling papers. Okay. So we're gonna draw two triangulars. Go like this. Kind of make them look the same. And we're going to go over some topics. So let's mark some letters here. In the spirit of originality, I'm going to call these triangles A, B, C, and D, E, F. I know, it's never been done, right?
But so never.
Yeah. Thank you for understanding my originality. I stayed up many moons thinking about it.
A fortnight.
2 weeks indeed. All right, so
for what?
this is 4-5. Good job.
Oh, I drew it in 4-4.
Let me ask you, it's okay. Let me ask you this. Is BC congruent to EF? And I'm going to write it. Is BC congruent to EF? Question.
We have no given.
Not yet.
Not yet, and we don't know. That's right. We don't know that they're the same. Okay, so let me ask you this. Now, we're assuming that AB is congruent to DE. Now, is BC congruent to EF?
No.
No, we don't know that, right? We don't know. It's not enough. Okay, what if I said this? Now let's assume AC is congruent to DF. Now can we say, do we have enough information to say that these bottom lines are the same as well?
Yes.
What about the flashlight effect?
No.
Flashlight effect? Yeah, I know what you're saying, but I'm still just asking.
Oh, okay.
Is this enough information? It's not.
Oh wait, yeah, no.
It's not enough info. It's not enough. Just because these two are the same doesn't necessarily mean the bottom's the same, because this one could be angled in all different ways. Okay? Green. Now, what if I said this angle is the same as that angle? Now, would this be enough to say, if these three things are shared, that the bottom sides are the same, please?
Well,
Yes.
yeah, because if the triangle itself is congruent, then all the sides are congruent.
Yes. Does that make sense? We're going to say it again. If the triangles you know are completely identical, then you know that every piece of the triangle must be identical too.
That's what I'm saying.
We talked about this before briefly, called it the house analogy. Assuming that two houses are completely identical, let's say, right? You're looking down at the plane and you say, wow, those houses look exactly alike. Looks kind of boring, but still, they're all completely alike. And if I said two houses are completely identical, tell me about their bathrooms, you would say? Yeah. Go ahead.
The bathrooms are exactly the same.
Bathrooms are exactly the same, and their garages and their kitchens and everything. So the point is, if we can prove triangles congruent first, so I'm going to put these congruent. These two triangles are congruent by which law?
SAS.
SAS. Is that clear? Any questions about that? Are you good
Side
with that?
equals side.
Okay. SAS. Now that the triangles are congruent, I can safely say that every part of the triangle is congruent as well. So I can say 3, 3. And that's what this stands for. That's what this stands for. Okay? What this stands for, and let's actually write it over here. CPCTC. Is that in there?
Yeah.
Okay, good. It stands for corresponding parts. Okay, we're going to stop it there. Corresponding parts. In question, in this case, BC and EF. These are two parts that are corresponding, that are kind of like the same on one as to the other. Same with angle B and angle E. They're corresponding parts. Same with angle C and angle F. They're corresponding parts. Okay, corresponding parts of congruent triangles, corresponding parts of triangles that are already congruent are congruent as well. So I'm going to take off your friends.
Bye-bye.
Yeah. It'd be funny if you guys are like, aww.
Aww. No!
And it's even funnier that you don't mean it, because it's just a drawing on the board, you know? Doesn't matter.
It's okay. It's sketched in my heart.
Corresponding parts of congruent triangles are congruent as well. Right? That's what it means. That's what it means. Any question of the definition, please feel free. If you have two parts of triangles that are already congruent themselves, the triangles, then the parts are congruent. Okay, and we're going to do one proof to demonstrate this. All right, we are going to do bow tie.
Bow tie.
No.
Bow tie pasta, is that better?
Yeah, that's better.
So please draw your bow tie.
Bow tie.
One proof, that's all we're doing today. And we have B, we have A, we have C.
Wait, so what is CPCTC?
It is the law, is the abbreviation that stands for this.
Oh.
That basically means if you have congruent triangles, then all their pieces are congruent too.
Wait, how did you get to F? Like it's a,
I know,
you went like from D to F.
I know, I know.
Just like it is in grades.
Just like it is in grade.
Huh. That's funny.
Right.
LOL.
Prove.
Lol.
So before today's lesson, what was the goal? Proving what?
Corresponding.
Yep. SAS, SSS. What do those rules prove?
The congruent.
The triangle.
Congruent triangles, right. As a brief review, what are the 4 ways, the 4 laws that can prove triangles congruent? Can you give us one?
SSA.
No, not SSA. Remember, it's backwards, it doesn't work.
Oh, so SAS.
SAS, that's right. SAS, you know what I'm going to do? I'm just going to do proves triangles congruent. So we heard SAS. Yes?
SSS.
SSS. Yes?
AAS.
AAS, that's right. It's a theorem, yes? And?
ASI.
ASI. All right. So these prove triangles congruent. All right. That will still be our goal, except now we're going to prove pieces congruent, CB and FD. All right. Our overarching goal will still be to prove triangles congruent, and then we will say, once the triangles are congruent, then the pieces are. Are there any questions about that philosophy? We'll prove the triangle is congruent first, then we can say, oh, any piece of each one is the same then. Please?
So does that mean if we were writing a 2-column proof instead of the last one being
Right.
triangles are congruent,
Yeah.
and the reason would be SSS or any of those laws,
Right.
it would be CB is congruent to FD, and then it would be CPCTC?
Right. It's the last line of a triangle proof. Very good. Let's go ahead and do that. Based on our given that we have here, statements and reasons. Okay, so based on the given, let's say CB is parallel to DF. That's one given. And we could also say A is the midpoint of BD. All right, we'll mark that as the given.
Givens.
You kind of look like a sloth and
A
not
sloth?
monkey.
That is the sloth.
Oh my god.
Don't you mean given? Like, yeah, you get it. Come on. They sound exactly the same. Sloth, given.
Oh, I thought you meant
Sloth.
like given. Like the given.
Like the monkey?
I thought that's why you were being a monkey.
Exactly. Great. I love delayed humor. It spreads the love. It's kind of like a burst of butter in the popcorn. Like, oh yeah! I've been eating for 20 minutes. Okay. So as I stand in the way of the monkey, here we go. Now, according to our picture here, I'm going to stand out of the way completely here so we can see it. We're trying to prove that the triangles are congruent first. Let's go ahead and try that. What can we do to prove that these triangles are congruent in any order? In any order? Okay, give us one thing, please. Loud.
Alternate, if lines CB and DF are parallel, then angle CBA and angle FDA are alternate interior.
Right on. So that was the hardest part of the proof. So I'm going to mark these parallel. So before we get to your point, let me ask you this. If lines are parallel, does that mean they're congruent also?
Nope.
No.
If two lines are going in the same direction? No, right? Because check these out.
Longer.
Exactly. These lines are parallel, but they're not the same in length.
Just says they're going the same direction.
Just means they're going the same direction. Very good. So these lines are parallel. Doesn't mean that they're the same. But parallel lines form angle relationships, as we heard. So what could be one angle relationship that was previously said here? Please, sir.
Alternate interior.
Which two angles are alternate interior?
CBA and FDA.
CBA and FDA. Cool. In this case, can we use one letter because we don't have any confusion about what you're talking about? You said CBA, right?
Yeah.
Could I say angle B?
Yeah.
Because there's no confusion about what angle B is in this case. So let's do that for simplicity's sake. Angle B is congruent to what? Anyone? Everyone?
Angle D.
Angle D. And let's mark the picture. Very important, mark the picture. Question, please.
No, I have another.
Okay, cool. Nice. Then give me a chance.
Okay.
B and D are the same.
Wait, what's the reason on that?
Exactly. What's the reason, please?
If parallel lines and alternate interior.
All right. If lines are parallel, then what?
Alternate interior.
Angles.
Angles are congruent.
Right. Let's talk. Spelled with a T. Alternate interior angles congruent. Okay, so we have an A here. Cool. Maybe we could do another one? Yeah?
But also,
Yeah.
since A is the midpoint of BD,
Mhm.
wouldn't BA be the same as AD?
That was yours. Yeah, it's true. You know what I want to do? I want to do the other alternate interior one just for our health because I have a lot of space here. Okay, so you want to take it? Go ahead.
Okay, so angle C
Yeah,
is congruent to angle F.
cool.
That was mine.
There's no ownership, friends. Okay, angle C and F, we can put those down as another A. Angle C and angle F. Okay, so while we're on the topic, we heard the midpoint one. So the midpoint one said here and felt there, right? So if A is the midpoint of BD, A is the middle of BD, that means A cuts BD into two pieces. Those two pieces are?
Equal.
And what are they? What are their names?
BA.
BA and DA. Let's mark it. 1, 1. Let's do it with 2 so it's more clear. Okay, so BA is congruent to DA. And how did you know that these two pieces are the same, please?
Because B is the midpoint, so it means A is the midpoint, so it means it cuts it.
Right. You said the word midpoint, and that's right. So the word is midpoint. Okay, what's your question, please?
And my question is, can it also be angle? Because theoretically, what was I going to say? Oh, that they're vertical angles, so that could be another.
Vertical angles also exist here. That's right.
Right.
And so we could say that these two are the same.
And that would be 3 angles. Is
Right,
that possible?
but that's not one of our 4. Good question.
So wait,
If we had angle, 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 that's not enough to prove that the triangles are congruent.
so there
Please.
could be multiple ways to
There are multiple ways in this case. Nice, very good, very good.
So it could be either angle side angle or angle angle side.
Yeah, depending on what we do. So we could do vertical angles if we wanted these two. That would be CAB, C-A-B,
Cab.
congruent to FAD, F-A-D. That would work too if we wanted to do it, and you could put it down, right? But in this case, we'll just go with what you guys said. And looking at it closely, we see 3 congruent statements. 1, 2, 3. And now looking closely, is this enough to prove our primary goal, which is to prove triangles congruent? Is this enough?
Yeah.
It is. So which theorem, yes? Right?
AS.
AAS. Why AAS?
Because the B is congruent to angle D and angle C is congruent to angle F are both A's.
Right.
And the last one is.
Is it between them or not?
What?
Is this side between the 2 angles?
No.
No. So just like it's spelled, the side is not between the 2 angles. Yes?
For the definition of midpoint, can you also
Yeah.
do line CA is congruent to line FA?
No.
Why not?
Who can answer a question?
Wait, what did you say?
For the definition of midpoint, could we also say that CA is the same as FA? It's a really, really important question.
No.
Okay, in the back, please.
Because it's not given that A is the midpoint of CF.
Right.
But
Not given.
It's not given that A is the midpoint of CF. Please.
But because the lines are parallel and they're also like, yeah, because the other lines are parallel and then
Uh-huh.
they're intersecting. Does that mean that A is also the midpoint of CF?
It turns out that A will be the midpoint of CF because the triangles are the same. All right?
Sorry.
It's okay, winter. Okay, so now we say triangle what? Please.
Triangle CAB is congruent to triangle DAF or FAD.
FAD.
But isn't that not what we're trying to.
Correct, it's the one step before what we're trying to prove. Now we get to the house analogy. We say, if the 2 triangles are completely identical, then aren't their parts also identical? Yes. So which parts are we trying to prove? Please.
Well, like, that's line CB and FD are congruent.
So is this true now?
Yes.
Why?
Because the triangles are congruent.
Very good, that's all it is. So put this in. Is this in the frame?
Oh, because of CPCTC.
Yeah. CB, because of CPCTC, that's right. FD, CPCTC. That's it, we're done.
Mazel tov.
Mazel tov. Ooh.
It's
You
okay.
wouldn't end it with
L'chaim.
No, right. If you would end it with AAS, you would end it with AAS
it wouldn't prove
if these were triangles, right? Okay, any other questions? Yes?
How could you explain CPCTC without if you don't remember it?
That's a good place to end. Who can answer that
I
question?
can't see the board.
How can you explain CPCTC if you don't remember the actual letters? Okay, we have a thought. Yes.
If every part of a triangle is the same, then the lines are the same.
Close, close. But we don't know that every part of the triangle is the same. How about just saying that the triangles are? Yes?
If the triangles are the same, then therefore every side and angle will be the same.
Okay.
If the triangles are the same, then the parts are the same. Yes?
So with this kind, that'll always happen. CPCTC will always happen with 2 triangles, right?
After you prove the triangles the
Yeah,
same.
no, but like that kind of picture.
If you see a piece the same as a piece,
Okay.
then that'll be CPCTC. If you see triangle congruent to triangle, you'll end on this line,
Okay.
right? Because we're done with proving triangles.
I
Yes?
just have another question.
Please, I'd like it.
What happens to the parallel lines?
What do you mean what happens to them?
Because you wrote A, A, S,
Yep.
but are you ignoring the parallel lines when you wrote
As
that?
you mean as a congruent side?
Yeah.
the goal was to prove these congruent, and so we did it. But in the efforts to prove these triangles congruent, we couldn't use the fact that these are congruent because we didn't prove that these are congruent yet. The only things we did prove congruent are these angles and this side. You know what I mean? So once we did these angles on this side, then we said, okay, now we have the whole triangles the same here. And then once you have all the triangles the same, then this is true because it's a piece. So I could say that these three are the same as this. I could say that now. I could say everything's the same.
Yay!
You know, turns out that everything already is. All right. Got any more? Okay, you guys, give yourselves a hand. Yay!
Oh yeah!
You didn't cut it off. Say bye, everyone. Bye.
Bye, yay, Matt.
Bye.